Hi guys, here's a 5-minute crash course on Docker for machine learning. Let's get started. Docker is the number one most used developer tool in the world. And do you know why? Because it solves the number one most annoying problem that every software engineer and machine learning engineer faces every day. And that is having an application, for example, a training script or a REST API that works perfectly on your local machine but doesn't work in production. But it worked on my machine. So let me show you how to start using Docker right away so you don't face the problem anymore. So imagine you have a very minimal machine learning project with a requirements file where all your Python dependencies are specified, and then a train script that basically reads data from an external source, for example, a feature store, preprocesses it, trains a model, and then pushes the model to the model registry. So essentially, a training pipeline. The training pipeline runs perfectly on your machine, but to make sure that it will also work perfectly when you deploy it to the production environment, you need to Dockerize it in 3 steps. Step number 1, write the Docker file. The Docker file is a text file with a set of instructions that you commit in your repo. These instructions tell the Docker engine how to build your environment. For example, a Docker file can look like this: a sequence of instructions starting from selecting the base image from which you build the container, then setting environment variables both at build time and at runtime. In this case, we're setting Python buffer to make sure that Python output is shown in the Docker logs. The next step, we copy the application code from outside the container to the container. Then we set the working directory, and that applies from all the commands from now on. Then we run pip install all the dependencies from our requirements file. And then finally, we set the entry point. This is the default command that will be executed when we start the container. Once you have the Docker file, you need to go to the second step. Build the Docker image. From the root directory of the project where you have your Docker file, you simply go to the command line and write Docker build, and then you pass the name of the image. Docker images are first-class MLOps citizens. So what you typically do is you build them, and then you push them to a remote Docker repository. From there, your production systems can later fetch these Docker images and run containers from them. Step 3, you run the container locally. To test that your Dockerized training script works, you simply need to start the container locally. And for that, you use the command docker run. You pass the name of the image, and that's it. And if it works, you're done. Because this is the magic of Docker. If it works on your computer, it's also going to work everywhere. And here's a bonus. The Docker file that I shared before works, but it's terribly slow to build. And this is because Docker file instructions are layered as a stack, each instruction adding an extra step in your build process. And each of these layers can take a lot of time. So to speed up builds, Docker Engine uses a cache, which means that a layer will only be rebuilt if it has changed or comes after a layer that has changed. So for example, in your training script, if you update it, layer 3 will change, and this will force the rebuilding of layers 3, 4, 5, and 6. Layer 5 is when you install the requirements, so even though your requirements file didn't change, you will reinstall the exact same dependencies, and this is a complete waste of time. So what's a better way to design your Docker file? Instead of having one single copy command that copies both the requirements file and the application code, you first copy the requirements, you install the requirements, and then at the end, you copy the rest of the code and you set the entry point. So this way, when you update your code, the layer where the requirements are installed will not be rebuilt. So your Docker builds are going to be way faster. So that's it for today. I hope you learned something new. And if you want to get more hands-on MLOps content for free, subscribe to this YouTube channel